Alright folks, this video is about the last practice problem we have in chapter 13. It's slides number 32. Let's take a look at this problem. In this problem, it's asking you to determine the reaction order and the rate constants for this decomposition reaction of the C4H8. And then it asks you about the rate when the concentration of the C4H8 is 0.25 mole per liter. Before we start, let's review what we learned about the integrated rate law of the first order reaction and second order reaction and zero order reaction. First order reaction integrated rate law tells us between the length AT and the time, it's a linear relationship. And the second order reaction, if it will be the 1 over AT and time, it will be a linear relationship. Zero order reaction between the AT and the time, linear relationship. Now what do we need to do to solve this problem? You got this table, time change, and the concentration change. Okay, and what you need to do is just calculate the 1 over concentration of the C4H8, okay, and the length concentration of C4H8. Okay, you calculate the values based on the concentration of the C4H8. Now you draw three graphs. The first graph is the 1 over C4H8 concentration versus time. Second graph is the concentration of the C4H8 versus time. The third graph is the length C4H8 concentration versus time. Okay, now what do we need to do? Once you get your data, you use the first order, second order, and zero order reaction model to fit your data. For instance, in first graph, we use the second order reaction model to fit our data. That is this straight red line. As you can see, not all the data points are on this red line. So it tells us this is not a perfect fitting. R value is 0.98 or 0.99. It's close to 1, but it's not perfect. And let me remind you, both R and R squared value can be used to evaluate how good your fitting is. If R or R squared value close to 1, that means your fitting is excellent. Alright, so since the second order reaction model does not give us a straight line for the data points, this is not a second order reaction. How about the second graph? Second graph is between the C4H8 concentration and the time. Again, we use the zero order reaction model to fit the data. Okay, zero order reaction model gives us this red line, but not all the data points are on this straight line. So it tells us R value is 0.99. Again, it's not perfect. Okay, again, tells us this is not a zero order reaction. How about the third graph? When we use the first order reaction model to fit the data, as you can see that all the data points are on this line, and R squared value equals to 1. So this is a perfect model. It tells us this reaction is a first order reaction. Okay, so we solve our first problem, the reaction order. So the rate equals to K times the C4H8 to the 1, first order reaction. Okay, now how do we find out the K? Since now we know this is the first order reaction, we just need to focus on this the third graph. And remember, in first order reaction, the slope is negative K. We have our slope right here, negative 0.011214. You just take the absolute value of the slope, and that is your value of K. So the rate law of this reaction would be 0.01 1, 1, 2, 1, 4. Unit, second to negative 1. Okay, remember when we discussed the unit of the first order reaction, it's time to negative 1. Time here is a second, so it's second to negative 1 times the concentration of the CFH8, first order reaction. You don't have to show 1. All right, we solve our problem A, the rate law of the decomposition reaction of the CFH8. All right, now let's take a look at the B. Since we've already known the rate law, and it's asking you about the rate when CFH8 is 0.25 mole per liter, you just need to plug this 0.25 mole per liter in this equation, and that will give you the rate. So the rate equals to 0.011214 second to negative 1 times 0.25 mole per liter. Okay, so, and my calculation gives me this 0.0028 mole per times second to negative 1. Okay, two significant figures. All right, let's summarize what we did. We get our data. We use the 3 reaction models to fit the data. Which graph gives you the best straight line? You will know the corresponding reaction order. Okay, so that is the strategy we are using here in this problem. And in your experiment, in your lab, you are going to use the same strategy. And I hope this video can help you get a better understanding about what we need to do when you got this kind of question. Okay, again, please let me know if you have any questions or problems, and I'll work with you. All right, bye.